Good morning, all, and thank you all for coming. Now, this talk is on the incredible health benefits of fasting. My interest into this became after I personally started fasting, and I'll take you I'll just describe to you what are all the benefits of fasting. Now, I have divided it into four sections. First one is introduction and fasting protocols. Second one is the stages of fasting. Third one is a metabolic, hormonal and cellular changes during fasting, and fourth one is the health benefits of fasting. Of which the third one is a bit of theory, but it's essential to know theory so that you get motivated to fast. First one is introduction. So fasting is defined as a voluntary abstinence from food for specific recurrent periods of time. And it's different from starvation in basically in two things. Fasting you do when there's plenty of food around you, as is the situation now, whereas starvation occurs when there is no food available. And fasting, there is no muscle wasting as such, whereas starvation becomes so much profound that muscles also waste away. So fasting is basically different. Which one is more challenging is fasting, because you have to fast when plenty of food is around you, whereas starvation there's no food. Now fasting versus calories restriction is another thing. There was an article in NEJM which was about fasting. After that, there was another article which said that calorie restriction and fasting have the same benefits, which is not true, because they have the same benefits as far as weight loss is concerned. But when you go into the deeper aspects of fasting, calorie restriction alone cannot rematch the effects of fasting. And fasting versus ketogenic diet. When you fast, you enter into a state of ketosis. But all the benefits of fasting are not mediated only through ketones. The usual time period for fasting is 12 hours to 3 weeks. Now, 12 hours fast is a basic fast which everyone has to do every day in your life. Now, as you can extend it to 16 hours, and 8 hours you can eat. So that 8 hours is called the feeding window, and 16 hours is called the fasting window. That is a 16-8 fasting protocol. That is also very easy to practice and very well established fasting method. Another one is OMAD, which refers to 1 meal a day. A person eats lunch or dinner and eats again only the next lunch or next dinner. Then we have alternate day fasting, weekend fasting, where you can eat whatever you want for 5 days and then fast for 2 days. Or you can have prolonged fasting, where you can continuously fast for any amount of time you want. Now, how to practice this? Most of the people here might not be practicing fasting. First thing you have to, most of the people are probably eating 5 meals a day, 3 meals plus 2 snacks. The first step you have to do to prepare to practice fasting is stop snacking. The second thing you can do is early dinner and late breakfast, so that will make it at least 12 or 13 hours of fasting. And the next step you can do is omit breakfast. That is the easiest, because most of the people are not hungry at the morning hours. So best thing is to delay breakfast and combine it and merge it with lunch. So you'll have only lunch and dinner. So that essentially it will become a 16-hour fast. And prolonged fast is you can do once or twice a year. What is allowed during a fast, just to keep your psychologically boosted, you can have black coffee, that means without sugar or without milk, black tea, green tea, lime in water, vitamins, electrolytes, etc. And one thing which has to be avoided at all cost is protein. Protein, even minute amounts of protein will stop the fasting and will convert the metabolism to a feeding state. Now, record for the most prolonged fast goes to this man called Angus Barbieri from Scotland, who he fasted for 382 days continuously, only on water, tea, coffee, vitamins, minerals and yeast. And he lost weight from 214 kg to 89 kg over a span of, say, 382 days. Now, how to get rid of hunger is the most frequent question that everyone asks. And there is only one answer which I have for that. Only one answer is eat real whole food. Real whole food, that's the answer to that. So real whole food means vegetables, fruits, nuts, which are real and whole without any cooking. For example, this food lunch, I had carrots that is not cooked or boiled, then pomegranates, which is again not cooked, real food. Then the third one is green gram, cheruvire, that has to be boiled, otherwise you cannot eat it. You just have to boil it in water, that's all. That's the cooking that's needed. Then chicken is actually grilled one. Then one egg and curd. So this is my pattern of balanced diet. That is one vegetable, one fruit, one plant protein, one animal protein, one fermented food. That is, if you have these sort of real whole foods, it's very unlikely you will be hungry after 6 or 8 hours. Anything else is unreal. For example, dosha, idli, chapati, puri, parota, all these are unreal, unnatural foods. These foods will create insulin spikes and will only produce hunger after 6 or 8 hours. Now we move to the stages of fasting. Now we'll getting more into the science of it. The stages of fasting was first described by Dr. George Cahill, who made this landmark article called Fuel Metabolism in Starvation. So once we have 3 or 4 fuel sources. First is when we eat, we have glucose as a fuel. Secondly, we have glycogen, which is stored in liver and muscles. Thirdly, we have muscle protein, which also may be used as fuel. And fourthly, we have fat, which is stored as triglycerides in our fat. That also can be used for fuel. So once we eat a meal, the first stage is called the feeding stage, which is 0 to 4 hours. All the glucose that enters the bloodstream gets absorbed by liver, kidney, muscles, and brain, as well as other organs. So all the organs are now depending on glucose for its metabolism. Now after 4 hours, this glucose supply in the blood has gone. Then the first thing that happens is we utilize the glycogen that is stored in the liver, which gets converted to glucose and it's sent back to the bloodstream. That is called the post-absorptive state. So the first fuel what we are using is glycogen from liver. And thirdly, when the liver glycogen starts falling, we enter into a phase called gluconeogenesis, where we create glucose either from proteins or that means amino acids. And these proteins are usually not the proteins of muscles. These are junk proteins, proteins which have already lost their function, misfolded proteins, dysfunctional proteins. They will be used for energy, for gluconeogenesis. So glucose will be created from these amino acids. Now stage 4 is ketosis, where fat from the fat stores, which is stored as triglycerides, comes to the bloodstream. It gets broken down to glycerol and free fatty acids. And free fatty acids can be used by all the tissues of the body except brain. So brain cannot, free fatty acids do not cross the blood-brain barrier, so they have to be converted to ketones. So we have 3 ketones: acetone, acetoacetic acid, and beta-hydroxybutyrate. These 3 ketones can enter in the brain, and this can be used as fuel by the brain. And stage 5 is protein conservation stage, where the patient will be in full ketosis. Gluconeogenesis also will come down because the muscles have to be preserved. So basically in fasting, what we have initially in the fed state, we have glucose. Then we go to a stage where liver glycogen is predominantly used. Then we go to a state of gluconeogenesis. And lastly, we go into a pure ketosis state. That will take after about 5 to 7 days to be only in ketosis. So these are the changes during fasting. Now let us go even more deeper. What happens at the metabolic, hormonal, and cellular level during fasting? So at fasting, the glucose levels comes down. Insulin level also comes down. As a result of this, the cells have an energy crisis because there is no glucose coming in. And when the cells have an energy crisis, all the ATP in the cells get converted to AMP. ATP gets converted to ADP. ADP gets converted to AMP. Now AMP, as the ratio of AMP to ATP increases, an enzyme which gets activated, which is called AMP kinase. Now, AMP kinase is an enzyme which is regarded as the master controller of cellular metabolism. Everything metabolic activity that goes inside the cell is controlled by this enzyme called AMP kinase. So AMP kinase, it has many functions. It enhances fat oxidation. It causes a translocation of GLUT4, that is glutamine transporter, from the cell onto the cell surface. So by which cells will be able to absorb more insulin. When GLUT4 has been translocated to the cell surface, the cell surface, the insulin sensitivity of the person will increase very much. So that is how in fasting can improve the insulin sensitivity, because AMP kinase causes translocation of GLUT4 onto the cell surface. And it promotes a thing called autophagy. So autophagy refers to recycling of old dysfunctional and misfolded proteins. And these proteins are either broken down may enter into gluconeogenesis, or it may be more newer proteins may be created based on these old dysfunctional proteins. So this is called autophagy. So autophagy also, the starting point is from AMP kinase. And AMP kinase inhibits another key hormone called mTOR. mTOR stands for mammalian or mechanistic target of rapamycin. So mTOR is again a master controller. It's a master controller of protein synthesis. All the anabolic activities of the cell are controlled by mTOR, and AMP kinase inhibits mTOR. So during fasting, AMP kinase activity goes up and mTOR activity goes down. And so because of inhibition of mTOR, protein synthesis goes down. AMP kinase also stimulates autophagy. And there is also a thing called mitophagy, where old dysfunctional mitochondria are destroyed and newer mitochondria are formed. So the destruction of old mitochondria is called mitophagy, and creation of new mitochondria is called mitochondrial biogenesis. Now, dysfunction of mitochondria is one hallmark of all major non-communicable diseases as well as normal aging. So when you fast, this AMP kinase stimulates mitophagy. So it activates key things like PINK1 parkin. So PINK1 causes the mitochondria to be bound to parkin, which parkin activates ubiquitin, and finally this mitochondria will be destroyed. So if you want to, AMP kinase, which is called the master control of cellular metabolism, increased activation of AMP kinase is very well known to prolong longevity. And suppression of mTOR is also known to prolong longevity, whereas increased activation of mTOR will reduce longevity. So if you look at this slide itself, you can know that fasting activates AMP kinase, your longevity gets improved, your insulin sensitivity improves, mitophagy improves. So all these fasting finally converges on increasing longevity. Then there are many other intracellular mechanisms which get activated during this fasting. So all these activate many signaling pathways that activates evolutionary preserved stress resistance pathways. So signaling means we have many genes in our body, some of which are not active, some of which are active. So when fasting occurs, many molecules are formed which signals transcription of genes which should have otherwise not been transcribed at all. So these signaling molecules, the function is to transcribe genes which are essential for cell survival and longevity. So fasting finally bolsters mitochondrial function, stress resistance, antioxidant defenses, and it upregulates autophagy. Now let us see what are the hormonal changes which occur during fasting. The insulin levels go down, glucagon levels go up. Now growth hormone is a very vital hormone in the sense that it is required to preserve muscles. So as the duration of fasting increases, the levels of growth hormone also keeps going up. That is basically to preserve muscles and prevent muscle wasting. So growth hormone increases by 300 to 1050%. Cortisol increases because fasting is a state of stress. Adiponectin, which is released by fat cells, increases during fasting. Thyroid hormones decreases because metabolism as such goes down. And this fasting is not conducive to reproduction, so estrogen and testosterone levels also will go down. IGF-1 levels also go down, and melatonin levels may also be improved by fasting. So the key players in this fasting are beta hydroxybutyrate, which is a ketone body which mediates many of these signaling activities. BDNF stands for brain derived neurotrophic factor. So inside our brains we have a thing called hippocampus, which is the only area in brain where neurogenesis keeps occurring throughout life, and BDNF is the main mediator of hippocampal neurogenesis that is activated by fasting. Similarly, AMPK, mTOR, PGC1 alpha is the master control of mitochondrial metabolism. All these are the key players which mediate the health benefits of fasting. Now the health benefits of fasting, Now, these are not studied in big trials or anything, but what have been observed in many case reports as well as large series is fasting improves all metabolic diseases. It causes weight loss, it improves insulin sensitivity, it lowers blood sugar and insulin levels, it improves all cardiovascular parameters like it lowers BP, it improves cholesterol levels, it reduces inflammation. It improves brain health and cognition, I was telling. Neuroprotection is mediated by a BDNF, protects from Alzheimer's and Parkinson's disease. It enhances mental clarity. It has longevity benefits, as I just told. It has anti-aging benefits. In the gut, it produces gut rest and repair of gut lining and reduces the symptoms of irritable bowel syndrome. It promotes microbial diversity. Fasting and during prolonged fasting, the immune system gets suppressed, but when WBC counts also go down during fasting, but then fasting activates hematopoietic stem cells to create newer white cells and thus enhancing immunity. It also has an anti-cancer effect because cancer cells have glucose as a major fuel. When fasting, this fuel is taken off. So it inhibits cancer growth. It enhances chemotherapy tolerance. It also improves mood by increasing dopamine and serotonin, and it reduces body fat percentage, unlike calorie restriction, which food will decide whether fat has to be present or not. Fasting reduces the body fat percentage and preserves muscle, so body composition improves with fasting. Thank you.
Questions from the audience?
Question. You can take water, coffee, tea. But there is also a thing called dry fasting, where people do not take water at all. So that is more risky thing. But the number of survival genes that will be activated by dry fasting is much more than water fasting. But dry fasting is something we cannot recommend because of the risks involved.
Sir, what will be our option during a short-term illness? How can we short-term illness?
That we don't know the answer, but fasting will cause recovery of most illness. If you look at dogs, for example, dogs do not eat when they are sick. No animal eats when they are sick. It's only human beings who eat when they are sick. If you are sick, if you fast, you will recover fast.
Sir, one question. There are people who are blessed with increased metabolic rate now. So how do their metabolism differ from the average person?
There are people who are blessed with
increased metabolic rate, who never get obese even if they don't do anything.
Okay.
So how does it differ? How do their metabolism differ?
That I don't know. If you have to, the metabolism is decided by 4 things. One is the resting metabolic rate. Secondly, by the muscle physical exercise, non-exercise activity thermogenesis. How much a person moves even when he is not exercising, and thermic effect of food. So if you want to improve your metabolism, you have to improve all these 4 aspects. Physical exercise, non-exercise activity thermogenesis, which is referred as NEAT, then thermic effect of food. With the food which has maximum thermic effect is protein. Last thing is resting metabolic rate. So if you strength train and build your muscle, resting metabolic rate also will go up. So finally, if you want to reduce your weight, you have to look at all these 4 factors.